All right, rhombuses and squares today. So just to recap where we're coming from, we had quadrilaterals. That's your big overarching umbrella of shapes, and that's everything that has four sides as long as they're straight edges and closed, so we know that. And then off of quadrilaterals, we had the parallelograms. And of course, in order to be a parallelogram, you have to have two pairs of parallel sides, but there are a lot of shapes that do that. So if you have a shape with four sides and two pairs of opposite sides that are parallel, and all four sides happen to be congruent, that's how we land on the rhombus. Okay, so rhombus is a quadrilateral So everything that came with quadrilaterals belongs to a rhombus as well. So that means its angles are going to add to 360. It's going to have four sides. It is also a type of parallelogram. So all of those fun facts that were true about parallelograms are also true about a rhombus. So consecutive angles being supplementary, opposite angles being equal, opposite sides being equal. What else? Oh, diagonals bisecting each other. All of those things that were true about a parallelogram automatically true about a rhombus. But, so that's kind of old news. What's new for the rhombus, obviously all four sides are going to be equal. All four sides are congruent. And then we're going to talk about the properties of the rhombus that only belong to the rhombus. Okay, so maybe I'll even make a properties of the rhombus. So these are going to be the things that are unique to a rhombus so that nobody else has. So we already know that it has four sides the same. So give me 1 second and I'm going to make you a rhombus here. Let's see if we can guess some of those other properties that the rhombus has that the others don't. Okay, so here is a rhombus. Oops, I didn't realize Colin was in the waiting room. Okay, so I have a rhombus here. We already know it has four sides. We already know that its angles add to 360. All the things that were already true about parallelograms are already true. But the rhombus has some things that are unique to just the rhombus. So if we recap with the rectangle had its own cool thing, and that was that the rectangle's diagonals were equal to each other. We don't have that in a rhombus, right? If you look at the two diagonals, you have a little short one here, and then you have a really long one here. However, there is something that's true about the diagonals in a rhombus. Anybody want to take a guess? Maybe if I actually put them in. Let me try. There's a diagonal. Let me see if I have a piece that fits going the other way. That one's a little too long. Let's see if I have something a bit shorter. Maybe this purple. Purple's a smidge too short. Hold on. Let's see if I... Yellow is way too short. Blue is way too long. Did I try orange? Orange is too long. I'll have to go with purple as best I can. Maybe I can sort of squish it. Not really. I'll just let it hover on top like that. All right. Everybody want to take a guess? Oh, I have a guess in the chat, and it's right. It is right. Oh, no. Well, it's close to being right. There is something to do with 90-degree angles and the diagonals. Do you see? Look at my two diagonals. Can you see that? Oh, shoot. You can't when I move it. They intersect at 90-degree angles. Do you see that? Let me zoom in. Look. How cool. Now, hold on. That's just this particular rhombus. Is that always going to be true? What if you had a more wide rhombus? Are those diagonals still going to be perpendicular? What if you had one like that? Well, let's see. I don't know if I have, I'll try and see if I have pieces that fit. Actually, I think another green might fit here. There's one, and let's see if I have one that fits the other way. That's too short. Let's try orange is too long. Oh, yes. Look, purple fits perfectly. Oh, look at that. Look at those diagonals. Are they still perpendicular? They are. No way. Now hold on. What if the rhombus that we were starting with just so happened to be a square? Right? Because couldn't that happen? Right? This is still a rhombus. It still has 4 congruent sides. That's all you need to make a rhombus is 4 congruent sides. I still have 4 congruent sides. Right? It doesn't matter that it's turned that way. That thing is still a square. So if I put in its diagonals, are they still going to be perpendicular? Well, let's find out. Let's see if I have, oh yes, yellow works perfectly. Hold on, let me get another yellow. Well, what do you know? What do you know? Yes, those diagonals are perpendicular. That does not happen with a normal parallelogram. Okay, let me show you real quick. If I just took any old parallelogram that was not a rhombus, give me 1 second here to make my parallelogram that's not a rhombus. Here we go. So here's 4 sides. They are not all the same, so this is just a parallelogram. Look at your diagonals. They are not going to be perpendicular. There's one, and then let's see if I have something that'll reach on the other side. Maybe blue is a little bit longer. Yeah. There's no way that those diagonals are perpendicular, right? Look at them. They're not even close. So this is a property that is unique to the rhombus, not to anybody else. There's no other parallelogram that has perpendicular diagonals. That is only for the rhombus. Okay, now a square is a rhombus, so a square gets it too. But nobody else does. Rectangles don't have that. And then if it's not even a parallelogram, it doesn't have that either. So, well, take that back. Kites have it too. Oh, shoot. And I think I just froze my camera. Let me just reset this real quick. So I should rephrase. The only parallelogram to have perpendicular diagonals is the rhombus. So that's a big star that we need. Okay, I restarted the camera, but it's not. Oh, there we go. the diagonals are perpendicular. Remember, that just means that they meet at 90-degree angles, if you forgot what perpendicular meant. Okay, and that is for any rhombus that you could possibly draw. If you just sketch in those diagonals, they are always going to be at right angles. Furthermore, since you already know that the diagonals in a parallelogram bisect each other, and you know that a rhombus is a type of parallelogram, that means that you still have these pieces that break apart. Hold on, let me get a red. Here it is. You're still going to have this piece the same length as this piece. These two are not going to be the same, though. You're going to have this and this, just like in a regular parallelogram. The only time you get all four little pieces the same is when you have a rectangle. Okay, so another fun fact about the rhombus, we can actually sort of see right in this picture that we just drew. I'm going to zoom in a little bit on this picture, but I'm going to try and get the whole image in at once. There we go. So if this angle right here is 90, of course that means that they're all 90. All right, so I have those 90-degree angles all the way around. Now, here's another thing that's so cool. See what we basically have turned this rhombus into? We now have four smaller triangles. You have triangles 1, 2, 3, and 4. Okay, and you know even more about them. They're all right triangles, right? Because they all have this right angle over in the corner. Guess what else? Not only are there four right triangles now, those four right triangles are all congruent to each other. Can anybody tell me how? Do you remember the options? We had side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. How would you say, let's just focus on triangles 1 and 2. How could you say that triangles 1 and 2 are congruent to each other? Which of these 5 do we have enough information on? Let's see who remembers. It's been a while.
Is it side angle side?
It is side angle side. Yes. You couldn't do side, side, side because you don't know anything about the third side, right? I don't know if these outer ones are the same. Oh, but I actually kind of do if I know it's a rhombus, don't I? But anyway, the way that we have it marked, I couldn't do side, side, side. I do have side angle side, though. A side, an angle, then another side. Same thing for triangle 2. Side, then an angle, then another side. I don't have a second angle, so I couldn't do either of these. And I can't do hypotenuse leg because I don't have the hypotenuse marked. So any Hoosers, yes, these two triangles are going to be congruent. Now, if two triangles are congruent, that means all of their parts that correspond with each other are going to be congruent, right? So now, even though I don't know what the measure of it is, this angle right here would have to be the same as this angle right here, because it matches in those two triangles, right? That's the same angle in each triangle. And if the triangles are exactly the same, then those two angles have to be the same. Well, we get to keep this going, right? Because now I don't have just these two triangles. I also have triangles 3 and 4 down here. Well, guess what? Triangles 2 and 3 are congruent to each other by side angle side also. Oh, did my camera freeze again? What the heck is going on with this thing today? Sorry. I don't know why it's freaking out today. All right, so anyway, angles 2 and 3 are going to be congruent by side angle side also, which means that this angle that matches with this one up here is going to be congruent. And then I get to say the same thing over here. So now you have all 4 of these little mini angles that are going to be equal to each other. But that's not all. Guess what else? You have the same thing happening with these other angles. This angle matches up with this one, which matches up with this one, which matches up with this one. Every single rhombus works the same way. When you draw in the diagonals, look what they have essentially done. They have taken each of the big angles in the rhombus and they bisected them all over. Every angle is getting bisected by the diagonals of the rhombus. What? I know. So let's add that. So not only are the diagonals perpendicular, but the diagonals also bisect the angles of the rhombus. Diagonals bisect the angles of the rhombus. Okay, does anybody have any questions so far? No? All right, so I'm going to try and put this all together. So I'm going to draw for you a rhombus, and I'm going to give you just a little bit of information and see if you can find the rest. Okay, where am I going to stick this in? I'm just going to turn to the next page. So hopefully you have this. All right. I cleaned the whole notebook on Friday, so I got lots of pages. Okay, let's do a rhombus that looks like this. Okay, so given that this shape is a rhombus, not a great one because I'm not so good at drawing straight lines, apparently. That's so much worse.
Killing it today, Miss Sabia.
I tell you, I'm off my game because I don't have any nail polish on, so I feel like all weird. I fell asleep. I took it off, but I never put any back on. All right, so that's my rhombus, A, B, C, D, and we'll have a point E in there. So A, B, C, D is a rhombus. I'm going to give you a little bit of info, and then I'm going to give you a list of all the other pieces that I want you to find. Oh, gosh, I'm so sorry. I'm still fighting with the lighting in here. Let me try putting this thing over it. That seems to be a little bit better. Okay. Let's give you the following. I want you to find I think I should use variables instead of numbers. Sorry. God. It's a day already. X, y. Let's make this 30 degrees right here. So find me z, find me a, find me b, find me c. Let's say that this is 5. And let's say this is 4. So what did I do? A, B, C. I'm up to D. I need you to find me D, which is the length of BE. F. I think that's enough. All right. So find me the values of the variables A, lowercase, A, B, C, D. Did I do an E? A lowercase e? I apparently skipped a lowercase e, but I have an F. And you need X, Y, and Z. Okay. So I'm giving, actually, let me put them in different colors. Here's the info that I'm giving you. I'm giving you that this side is a 5, so I'll put that here in blue. And I gave you this 30-degree angle. And I also gave you that this side here, EC, is 4. So I claim that you can find all of the rest of this if I just give you that.
Okay.
You don't have to go in order. You know X and Y right now. I'm telling you. So I'll even put little degree symbols on all the ones that are angles. So X and Y are degrees. Z is in degrees. A is in degrees. B is in degrees. C is in degrees. Those are all angles. And then F and D are side lengths. Try it. See how many you can get. Remember that this thing is a rhombus. Kira, that's right. Keep going. So if it's a rhombus, I also claim that you know F kind of right away, right? Kira's on a roll. I don't know about the rest of you. Feel free to send me your answers. I'll give you guys one more minute to get as far as you can. Hopefully you found most of them. James, that's right. Okay, so let's start walking our way through some of these, okay? There was a few that I told you right away that you know without doing really any math. If you know that this thing is a rhombus, which you do because I told you and I wrote it up here. So we know this thing is a rhombus. That means that I know that all four sides are the same length. So if this is 5, that means this is 5 and this is 5. And oh, letter F is going to be 5. Okay, so F is just 5. Let me fill that in. I'll fill in over here as we go. All right, so that one was easy. Another thing that we just learned about rhombuses is that their diagonals are perpendicular to each other. So that means these two angles right here, X and Y, have to be 90. If I asked you for this angle, it would also be 90. If I asked you for this angle, it would also be 90. But I only asked you about angles X and Y. They are each going to be 90. They have to be because diagonals in a rhombus are perpendicular to each other. So that means X is 90 degrees and Y is 90 degrees. Okay, let's see. Where should we go? Let's finish up with the angles, right? Remember that all 4 of these triangles are going to be equal to each other. So that means all of these angles are going to be the same. Each diagonal is bisecting the angle, right? So if that one's 30, that automatically makes this one 30. They have to be the same. So now we have angle Z is 30. Okay, and then remember, since all 4 of these triangles are exactly the same, the angle that matches up with this one is this one. So these are also going to be the same. So angle A is also 30. If I asked you about this angle, it would also be 30. Okay, so all 4 of these ones are all going to match. So now I have angle A is 30. Okay. So let's take a look at what we have now. Remember, yeah, okay. If this one's 30, then this one's 30, right? So, well, no. Okay, let's look back up at this one. You have a right angle here, don't you? Look at this triangle. If this is 30 and that's 90, can't I find angle B? You bet I can, right? If it's a triangle, it has to add up to be 180. So I already have 90, and then another 30. That gets me up to 120. That means angle B has to be 60. Do you see that? Just angle B is just this piece right here. That one's got to be 60. So angle B, 60. Got it. Well, guess what? If angle B is 60, that kind of unlocks all of the other angles, because that means this angle would also be 60. And then the matching ones down here are going to be 60. So angle C is 60. And this one over here, if I asked you about it, would also have been 60. So now I know angle C, 60. Wow, we only have one thing left, which is D. And I know it's a little hard to tell, but D is supposed to be the length of side BE. Ooh, yes. I'm just checking back in the chat to see if anybody got this one right. Olivia has it right. Let me see if anybody else. I'm just scrolling back. Okay, the right answer for BE, or the variable D, is 3. What? There's no 3's on this page. How are you, Olivia? How did you get that?
I get a squared plus b squared equals c squared.
Perfect. You have right triangles, right? So I'm going to draw just one that's not quite so. I'm just going to, this triangle right here, I'm just going to redraw it down below. Not so messy. Okay? So here's what we have on just that triangle so far. I know that this side is 5, this side is 4, and this is a right angle. And I'm looking for this. So now when you kind of see it without all the extra stuff, hopefully you are like, oh yeah, that's just a right triangle. I can always do Pythagorean theorem to find the missing third side. You might have even noticed that this is a Pythagorean triple, right? Our favorite one too, the 3, 4, 5. So you might be able to get that value without even doing out the whole formula. But even if not, you're going to get it, right? So as long as you recognize, oh yeah, right triangles, you have all these tools in your toolbox to use on right triangles. Don't forget about Pythagorean theorem. That's why math, right? It's one of those skills that builds on the thing before it. So if you weren't great at the Pythagorean theorem section, it builds and it builds and it builds. So that's why it's so important to make sure that if you are confused that you ask questions before it, snowballs. But anyway, yes, 3 is the right answer. And that wasn't an X, it was a D. So that missing variable is going to be a 3. All right. How does all of this change if your original shape is a square instead of a rhombus? Remember that a square is a type of rhombus. So let's just think on this for a minute. So here's a square. Let me get this thing in screen, right? There we go. A, B, C, D. So this is A, B, C, D is a square. I'm going to draw in my diagonals. Are the diagonals still going to be perpendicular in a square? What do you guys think?
Yes.
Yes, because a square is a type of rhombus, so it's automatically going to be true. All right, so you already know that these 4 angles are going to be 90 degrees. I'm going to do the same thing that we did with the last one. I'm going to give you a little bit of information, and then you find the rest. Okay, so I'm going to give you, I'll put in orange the stuff that I give you. How about, I'll give you that the side is 8. And I wonder, all right, let me start giving you, I want you to find angles A and B and C and D and E and F. And here's side G. And then could you also find me H, which is, let me just say that this is point E in here. So H would be the length of BE again. Oh, how funny. So these ones will all be degrees. And then G and H would be side lengths. H is tough. If you get H, I'm pretty impressed. But try it. That's all I'm giving you. I'm not even giving you a single angle. Did you notice that? I didn't give you any measures of any angles. You already know all of them. Even these ones over here. Yes, you can find it. You don't need me to tell you. Find as many of them as you can. What's the angle on top? I'm not sure. I'm not sure what you mean by the angle on top.
It's the 4 that's on the top from the last problem.
Oh yeah, that's. Don't look up here. That's the old stuff. You want just that. James, all your angles are perfect. Good guess on H. Here, that's right. I'll give you guys a hint on H. Yeah, okay. I guess I'll. It might be easier to find H, which is just the distance from B to E, right? It might actually be easier to find the whole length of BD. That might be easier, maybe not. It's sort of up to you and your brain. Oops. So take a minute, see if you can try and find a way. I will tell you right now that H is not 4. All I will say so far is that I haven't gotten a right answer for H yet. I know Olivia's still working on it. If you've got an answer that you want me to, actually, I'll give you another hint. You will need a calculator to figure out H. So I don't even know it off the top of my head. Let's see. Kira, that is correct. Olivia, are you all set? Okay, I'll give you one more minute. Okay, I'm gonna have to start going through some of these. Olivia, it's not 64, but I know where you're getting that number from. All right, so let's start talking about these. G you get right away. If you know that this thing is a square, squares have all four sides the same, so G has got to be 8 as well, if that side's 8. Okay, so great, you're 8. Which means, oh, come on, my camera is frozen again. Jeez Louise. I'm so sorry. Technology. All right. So we have the image on this. Oh, wait, there it is. Okay. All right, come on. There we go. All right, so we know that G is going to be 8. That's fine. Since it's a square, I mean, I might as well just go ahead and fill in. Those sides are going to be 8 also, right? No big deal. Now, we also know that a square is a type of rhombus, right? And we just talked at great length about how those diagonals are going to be perpendicular, which means that you already know angle A is 90 and angle B is 90. In fact, all 4 of these would be 90, right? So if you wanted to draw them all in, you could. So all of those are going to be 90s in there. A is 90 degrees, B is 90 degrees. All right. The other, really, everything else you find because you have to understand that a square is not only a rhombus, but it's also a rectangle, right? So all of those fun facts about rectangles are true about squares also, which means that the lengths of the diagonals are equal to each other. And they bisect each other. So here's the key for the square. All of these 4 little pieces are the same because it is a type of rectangle, right? We see that in rectangles, so we also see it in squares. So now let's just take a look at this bottom triangle. Look at what you have. You have an isosceles triangle with a right angle. Remember what happens in isosceles triangles. If 2 sides are the same, that means 2 angles are the same, right? Those 2 base angles have to be the same. My gosh, see how this all works together? Oh, so cool, right? So if they all have to add it to be 180, I already have 90. So take 90 away from 180, that leaves me with 90. And then I have to split it equally between these 2. So what does that mean? That means all of these little ones, all these little angles are going to be 45 degrees. So you're 45 degrees, you're 45 degrees. And then since we know that the diagonals bisect the angles, that means C is 45 degrees because it matches, right? And F would also be 45 degrees. And if I had asked you about any of these angles, all of these angles would match. They're all 45, all of them. That's so cool. All right, so C is 45, D 45, E is 45, and F. All of those are 45s. So the only piece that's left is this pesky H, right? And I told you that you can find it. You definitely can. I'm so sorry. My husband's in the other room talking really loudly, so I apologize if you hear him on his call. But anyway, anybody want to give a final guess for H?
7.
Nope. You do need, so my hint
Close
was that it might be easier to find all of BD first. I'll give you one more hint too. Let me grab one of my cool highlighter tool thingies. Here's my last and final hint. I don't know if that helps. I'm trying to highlight this triangle. That's my last hint. It is a decimal. So I'll give you a second to think on it. Oh, thank you. It's, oh, Olivia, you're so close. Remember, what would H be? You're looking for just H. H only goes from H is supposed to just be from B to E. So just this piece right here, not the whole thing. Olivia, you are so close. You're like 2 buttons on the calculator away. Yes! Okay, Olivia got it. All right, so the right answer for H is 5.65. What? How in the world? Yeah, okay, so let me tell you why and how. I'm just going to round it to 5.7. 5.7. So let's talk about this. H is, look at this triangle that I highlighted in yellow. What kind of a triangle is it? Well, look over here. You have 2 45s. That means that's a 90-degree angle right there. And you have these two sides that are 8 and 8. So that's why I was saying it might be easier to find all of BD first, the whole thing, because you can just do Pythagorean Theorem, right? 8 squared plus 8 squared equals x squared, this whole side. Now, in order to find H is just half of that, right? Because those two, the diagonals bisect each other. So once I know the full length of BD, I can just cut it in half to find H. So if you do 8 squared plus 8 squared equals x squared, solve, 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 turns out that the entire length of the diagonal is 11.3, and then you just take half of it, right? So that's how we land here. Isn't that fun? I knew you would like that.
Please don't tell me that we have to like figure out that specific number like during the homework, because
No,
I'll
your
fail.
homework's actually
I'll fail.
Your homework is way easier than it should be, but it might trip you up because it's a lot of true false. So true false, I know you feel like is easy, and then you try them, and then you're like, what the heck, I got it, because now you only got a 50-50 shot, right? So I think I'm actually done with the notes, I believe. So let me, your homework is already in Delta today. So I'm going to hop over to Delta, and I'm almost positive they're almost all multiple choice. I mean, true, false. Or maybe not. I can't remember now. I made it so long ago, so I can't remember exactly what's on there. So let's look together. And if I need to make sure I show you anything else real quick, I will. Let's see. You guys are B block. And so make sure that you scroll down to homework 21, this one is. And I'll just share this with you real quick. So make sure you're in the right homework. Yeah, so just some true false. I'm not going to tell you them because you should be able to figure them out. I'll give you a hint though. If you're ever stuck, and you know, I know all of this is open notes, so you should just be able to go right back to your notes, but you know, pretend it's something where you don't have your notes. In a rhombus, the diagonals are always equal. If you can't remember or you're not sure, because I would hate for you, I never want you to sit there and memorize all the properties of everything. I want you to be able to figure out the properties on your own. So if I were you, if I couldn't remember, I would draw myself a rhombus and see if it really is equal. Just be careful though, because you want to, hang on real quick. You want to, whenever you are trying to do that and sort of figure it out on your own, I highly recommend that you draw like an exaggerated rhombus. So what I mean by that, let me just join with my iPad. Draw it for you. Okay. All right, so if I'm doing this one and I'm trying to figure out if the diagonals in a rhombus are always equal, I'm going to draw myself a really narrow rhombus. Don't draw yourself a rhombus so wide that it could be a square, because then things are going to be different. So don't do that. Draw yourself a very rhombusy rhombus, And then you can very easily say, all right, I'm trying to see if the diagonals are equal. Is there any way on earth that this entire diagonal is equal to that diagonal? I would say no. Right? So draw yourself an exaggerated rhombus and then check and see how you feel about whatever it's asking you. Okay, so yeah, I think most of these are, yeah. Let's just skip ahead. Oh yeah, okay, good. I did give you a couple of these, but I think they're pretty reasonable. So here you'd had to find the angle, the measure of the angle, just one angle though, AEB. That one should be pretty straightforward. Let's just jump around. Oh, some more true false. Are all squares rhombuses? Maybe, maybe not. Okay, so I did ask you just for the measure of a couple angles. Notice I don't want you, don't put in like, if you think the answer is, let's just pretend you think the answer is 45 degrees. Don't put in degrees or anything, just type 45. Don't write the word degrees, don't put the symbol for degrees, just the number. Okay, so whatever you think the answer is. Yeah, and I think that's pretty much it. So I think I covered everything that I wanted to. Does anybody have any questions? No, you sure?